Have you ever looked up at a utility pole and wondered how a tiny bird safely settles onto the wire? Those cables carry enough energy to power an entire neighborhood, yet the bird seems completely unbothered by the humming current beneath its feet. Birds are made of the same bone and muscle as any other animal. They don't have rubberized skin or a biological immunity to electricity. Their survival is actually a perfect demonstration of a basic law of physics that dictates how all energy moves from one place to another. Electricity is incredibly lazy. It will only travel if it is forced to move from a high-pressure zone to a low-pressure zone. This gap in electrical pressure is what we call a voltage difference. To see why that pressure matters, we can look at how water behaves in a river. Water on a flat surface just sits there, but when it hits a drop-off, the pressure change sends it rushing downward. Gravity pulls water down, and a voltage difference creates that same pull, dragging energy from a high point to a low point. In this scenario, voltage is effectively the height of that electrical cliff. Without a cliff, or a difference in pressure, both water and electricity simply stay put and remain harmless. Now, look closely at how the bird is actually standing on that wire. This notebook page shows the science behind the bird's posture. Notice how both feet rest on the exact same wire. Looking at the left diagram, when the electrical pressure is the same across both feet, there is no current flow. Because both feet are on one continuous wire, there is no cliff for the energy to fall down. There is zero difference in pressure between its left foot and its right foot. Since the bird's feet are at the same electrical height, the energy treats the bird like flat ground and simply continues on its way along the wire. You can imagine this like flowing down a lazy river at a water park. When your whole body is floating inside an inner tube, you move right along with the water's surface. The water doesn't crash through you. You are just part of the flow. The bird is the rider, and the power line is the steady level of the river. As long as the bird stays entirely on that one level of energy, it is perfectly insulated from the movement of the current. So when does a bird actually get in trouble? The danger occurs if a bird stretches its wings to touch a second neighboring wire, or brushes against the grounded wooden pole while still standing on the line. By touching two different things at once, the bird creates a bridge between two entirely different electrical pressures. Imagine being in that lazy river and suddenly planting one foot on a dry, stationary rock on the bank. The rushing water would immediately slam into you because you've given it a path to reach a lower point. In the same way, the electricity will aggressively surge through the bird's body to reach the lower pressure wire or the ground. The notebook confirms this danger in the second diagram. When the bird touches two wires, the energy has a path to flow. It travels up one leg, through the body, and out the other, which is why we see the label current through body. This is why birds are generally safe on power lines. As long as they stay on one wire, the current has no reason to enter their bodies. Once you understand how pressure and flow work, the sight of a bird on a high-voltage wire isn't a mystery. It's just a simple result of physics in action.